Let's perform a partial fraction decomposition to this rational function. The first thing we want to do is check the degree of the numerator. It is actually 2, and the degree of the denominator is actually 3. The degree of the numerator is definitely less than the degree of the denominator, so it's okay to perform partial fraction decomposition. Let's notice the factors in the denominator. We actually have a linear factor, x plus 2, and whenever we see linear factors with multiplicity of 1, we simply will think of a constant a. The other factor is an irreducible quadratic. So with irreducible quadratics, that means you can't factor them as linear factors over the reals. So irreducible quadratic is here an x squared plus 4. And this has multiplicity of 1. And if we see that, then we want to think of bx plus c that goes into the numerator. So let's illustrate that now. Why don't we write our algorithm 3x squared minus 3x plus 14 over a linear factor times a irreducible quadratic. So our algorithm goes something like this. We'll have a over the linear factor of x plus 2, and we have plus bx plus c over our irreducible quadratic. Now we are ready to solve for our a, b's, and c's. Multiply this equation by the least common denominator, and we get 3x squared minus 3x plus 14 is equal to a times x squared plus 4 plus the quantity bx plus c times the quantity x plus 2. We actually have a linear factor, so why don't we test this triple star equation? Let's test x equals -2. So when x equals -2, what happens to this triple star equation? Well, we get 4 times 3, which is 12. 12 plus 6 is 18. 18 plus 14 is 32. So we get 32 on the left hand side of this equal sign. And then we got 8 times a plus a quantity of 0. So this leads us directly to a. A is equal to 4. That's really nice. Now how should we get b and c? We are out of linear factors. So why don't we write a new equation? Let's call it triple triangle. Triple triangle is going to be 3x squared minus 3x plus 14 is now equal to, let's say it's a times x squared plus 4 times a plus bx squared plus 2bx plus a c times x plus a 2 times c. Now how is this helpful? Well, we already know a equals 4. So let's look at the coefficients in front of the x squares. We're going to perform a procedure called matching coefficients. The coefficient of x squared there must be, 3 must equal to what now? A plus b. But you already know a is 4. So b must be -1. How can we find c? Well, there's a couple different ways. But let's find c by looking at the coefficients in front of the x. So this says negative 3 is now equal to 2b plus c. But b is negative 1. So that means c is now equal to negative 1. All right. Looks like we got everything. So let's write our partial fractions. We have a to be 4. And then we have b to be negative 1 and c to be negative 1. So negative x minus 1 all over your irreducible quadratic. You could factor out the negative 1 and write it like this as well. So either one of these are acceptable. They're both good forms for calculus. And there you go. You performed a partial fraction decomposition with an irreducible quadratic and a linear factor as well.